All right, what's on the bench? New acquisition. It is a Keithley 427, and when you see the word current, you think, oh, it's a current source or current measurement. No, it's a current amplifier. So this is kind of keeping in the theme of some other things that I've done. These are transimpedance amplifiers. They convert current into voltage. And I did one that was one I used in an optics lab, a Mel's Griot. I did a little tiny board that I just kind of was playing with. And this is kind of a real deal. This is like somebody who really knows what they're doing. And so you input a current and it outputs a voltage. And so there is a gain knob, volts per amp, right? So 10 to the fourth gain, 10 to the fourth volts per amp, up to 10 to the 11th 10 to the 11th volts per amp. So very, very small currents this thing will amplify. And then there are some other items. There's max amps here. So I guess you can put a limit on it. Polarity, fine adjust here. And then there's a rise time measurement. So when I did my board, if you remember that one, I had a capacitor. In the feedback loop of the transimpedance amplifier, there's a capacitor on each resistor. And that's what this is. This just sets the roll off of the transimpedance. Power on and off. Looks like it's in pretty shape. Calibration data was 1998. That's not too bad, right? I used to think that was like, oh, that's not bad, very long ago. But yeah, 2000 was 26 years ago, which was just mind-boggling for me. Anyway, yeah, I say that before we turn it on, let's take a look inside. Everybody wants to know, where do I get this stuff? I bought this on eBay, so you could have had this too. I paid $41 for it, so there you go. All right, there's just 4 screws on the top here, and the top just pops right off. And there we go. Wow, it's super clean inside. Yeah, that is just super nice, and it looks more modern than from the outside. The case is kind of like really old school. You think just kind of crusty inside. But no, it looks very, very modern. I mean, it's throughput, but it looks very modern in my eyes. Very clean, very nice, easy layout. Yeah, and you can just see like, you can just see quality when you open this thing up. I'll zoom in a bit, but you just you know, you see a little adjustment on the front. It says fine, a little fine knob, you know. But take a look at the size of the potentiometer there. So yeah, it's really, really, really expensive potentiometer, 10K pot. Yeah, let's get you in a little bit closer so you can see some of these things. All right, you see some of those those resistors down there, those blue ones? Whoa, yeah, see those are, this thing has 10 to the 11th gain, right? So you're gonna have some really, really high impedance, high resistive resistors. Cora? C-O-O-R? No, Cobra, C-O-B-R-A. Oh, my flashlights crapping out. Let's see, can I read a value on these? Oh, here's one that's 100,000 megohms. That's a lot of zeros on that megohms. Yeah, so these are some pretty fancy devices there. So we can just kind of see from the layout here. Here's the input. So here's the input section. So these are some gain ranges here, and then these big resistors here are the max suppression filter. These are max things on that. This must have some big resistors on it as well. Oh, they're on the back side. You can't see them, but yeah, some of those real fancy blue things are on the back side of this PC board. And then not a lot of active devices. Looks like there's some cal adjustments here. Looks like there's a fancy op amp there that has shielding all the way around it. So that's probably the transimpedance device right over there. The front end is up to Keithley standards here. It's got Teflon standoffs on the input. So the PC board itself has too much leakage. So they put on Teflon standoffs, and then everything is point-to-point wiring. Might even be silver solder and stuff. It looks a little strange. So yeah, don't touch any of that. And then, so yeah, it's like this is the input section, and then here's some, like I said, here's some filtering, and here's some big filters over here for the roll off, for the how long does it take to settle. Really expensive capacitors over there, and then the gains or the roll offs are over here. There's a couple more pots. Can you see those? Couple more pots here for calibration. Let's see, it was calibrated by 1065 and inspected by 1300. Thank you. Power supply is down here. A couple gold standoffs down there just for testing the voltages. Oh, resistive. There's a couple pots there too for tweaking the power supply. You can set the voltage up more accurately there. Yes, indeed. So it is a beautiful instrument inside. A little bit ugly on the outside, but you know, you can't judge a book by its cover, right? So let's go ahead and put this back on. I think we'll look at the take a look at the schematic for this thing. All right, here's the instruction manual. Looks like it might have been typed. Model 427 in 1975. Keithley Instruments in Cleveland, Ohio, USA. So let's see here. Let's take a look at the specs. I bet you the specs are pretty wild. Let's see, can you read? Range, like I said, 10 to the 4th to 10 to 11th volts per amp. Output plus minus 10 volts, full scale. Output resistance less than 10 ohms into 30 kilohertz. 2% accuracy. Rise times adjustable, 1x and 3.3x from fast rise. Yeah, here are the rise times. Stability, current offset doubles per 10 degrees C above 25 C. Voltage drift is less than 0.005%. Yeah, current suppression, input voltage drop, less than 400 microvolts for full scale output. Overload, blah, 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 blah. Yeah. Let's see here. Let's see. The current amplifier is a high-speed feedback type amplifier, transimpedant, with a particular features useful for automated semiconductor testing. So you're looking at leakage of devices and stuff for automated semiconductor testing, mass spectrometry, and gas chromatography. So, yeah, pretty cool. Wide dynamic range, high speed. Typical resolution is 20 picoamps. Out of a 10 to the minus 8 amp signal with 100 microsecond rise time. All right, a lot of weird specs for these things. Let's see here, operation, blah, 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 blah. Yeah, so let's see here, what's a good thing to look at? I don't like these diagrams. I don't like those diagrams. Let's see, application. Okay. Yeah, here we go. I like these diagrams better. Circuit description. All right, so this is what we got. Something comes in, goes into the transimpedance amplifier with the gain, and then there's these filters here. There's the rise time filter, overload section here, And then the output, you can look at it on a, some type of graph or some type of oscilloscope, something like that. All right. Here's the filter. It looks like a Salin key type filter. Here's the power supply with the adjustments. So plus or minus 15. Typical stuff. Yeah. Component placement. Parts list. Very nice. Back in the days when you actually got everything. So you had right to repair. All right, let's take a look at the schematic here just real quickly. Input section here comes in 1 megohm input resistance into a FET. So they did some discretes up front and then they brought them into a QA201. IC388 tab does not, yeah, I don't know. I'm not sure what QA102-201, we'll have to look up that thing. But they basically, it's a JFET input op amp that they put their own JFETs on the front end to make it even fancier. Then here's all the gain settings with capacitors across them, everything. So it's typical transimpedance type stuff. And then the output has a buffer to drive. So it's got this class AB amplifier on the output. So yeah, there you go. That's all there is to it. Q201. I'm really curious what Q201 is. Let's look in the parts list. Let's see here. Q201 dual JFET. Oh, it's not even an op amp. It's a dual JFET. So they made their own op amp. It is a matched pair. Yep, no off-the-shelf stuff in here. Keithley rolled their own. All right, should we try it out? See if it works. Okay, before we turn it on, let me describe the measurement setup. We have the amplifier here. The output is going to be going to a voltmeter, so we'll measure how much volts come out of it. Okay. And then the input, we need to have some small currents. And I happen to have a Keithley 2400 that can output some really, really small currents. So let's go ahead and call it a current source. We will set the source to, let's set it to 001, 1 microamp. So we'll set it to 1 microamp. With a 21 volt compliance. Oh, I don't know. 21's fine. 21's fine. So let's turn it on. So now we have one microamp coming into this thing. And let's go ahead and turn it on. See if it blows up. It's got a light. And we are getting 11 volts. We'll hit polarity. And that doesn't change it to positive, does it? Okay. All right. Let's see here. Let me validate one thing. All right. Let's go ahead and change this to DC. Oops. DC current. Yeah, there we go. Milliamps DC. I'm going to take that 1 milliamp and throw it into this thing and see if it measures correctly. And 1 microamp. Yeah, this thing isn't going to go down very low, I don't think. Range, is this auto range? Auto, yeah. Yeah, this is not a great thing for low current. But this one is, let's see, let's go here to microamps. This has a microamp range on it. So let's put into this thing, and yeah, 0.9 microamps. So yeah, so we've got 1 microamp coming, out of this thing. So that's just a validation that we've got the right thing going on here. All right, so let's go back to DC volts. Put everything back in. All right. So 1 microamp times 10 to the 6 should give us 1 volt, right? And we're getting 0.7. Let's see here. Let's change some knobs because I don't know how to run this thing yet. And rise times. There we go. Okay, now we're getting 1 volt. Let's see, rise in milliseconds. Yeah, this slows it down. This slows it down. Also seems to change the value, which is maybe just dirty contacts or something. Okay, I've changed the Keithley to 100 nanoamps. 100 nanoamps, so 0.1 microamps. And I've increased the gain from times 10 to the 6th to times 10 to the 7th. And we're getting 1 volt out again. So yeah, there you go. Now I need some super tiny femtoamp thing. 10 to the 11th? I don't know. It needs real small currents.